Hello, my name is Gareth Morgan. I'm Professor of Medicine at NYU Langone in New York City in the United States. I'm here at the Waldenstrom's meeting in Prague. It's been a great meeting, and we have the opportunity to present some cutting-edge new data. Multi-omic analysis carried out on single cells offers a way of giving a great resolution of defining subtypes of cancer and Waldenstroms in particular. So we've been able to select out the tumor cells from a group of patients and then using this single cell multi-omic approach, look at mutations, structure of the chromatin, cellular phenotype, and expression of multi-genes to try and understand how Waldenstroms develops. And the interesting thing is we show quite clearly that Waldenstrom's isn't a single disease. There are two very distinct subsets. Both are characterized by expansion of memory B cell subsets. But in one of the subsets, the differentiation is blocked exclusively at the memory B cell stage, which confers upon it increased proliferation and different clinical symptomology and signs. Whereas in the other, they're able to complete partially differentiation towards plasma cells. So you can identify the kind of immunoglobulin secreting cells within the tumor mass. And these tend to have higher IgM levels. And so it's clinically important. But what might be relevant is how do you use this information to target your treatment better, to maximize the number of responses, to go from partial responses to complete responses, by identifying new targets for this specific for each of the subsets. So maybe the plasma cell-like subset may respond better to therapies that target plasma cells, and maybe the memory B cell component responds best to therapies that target that cellular phenotype. So I think it's a really important finding for patients and doctors treating Waldenstrom's, because it gives us the opportunity to target and personalize our therapy better.